I bought the cheapest 5C Collet chuck available on eBay. Is it bad? Is it good? Can we make it work? We're going to find out. Welcome back to Cloud 42. I'm James. A couple of months ago, I was browsing on eBay and I came across a 5C Collet chuck for my lathe. It piqued my interest for a couple of reasons. First, it came with a back plate for the 1 3/4/8 spindle nose that I have on my lathe, which is a little bit of a unicorn. And second, it was only $150, including the back plate with free shipping. Now, to be clear, I'm not expecting it to be good, but how bad is it? If you're as morbidly curious as I am, let's go over to the bench and take a look. Well, this is the chuck itself, and on the surface it looks okay. The ground surfaces look ground. If I look at the register surface inside the end of the chuck here, it looks pretty good. It's just kind of rough bore down further in. And if you look way down in there, there's another ground register for the back side of the collet. So it looks okay. Replaceable index pin. And just a scroll, it's like a scroll chuck. It's not really a scroll, but you just use a key to tighten down and pull in the collet. And all in all on the surface, it looks okay. The mechanism's a little bit scratchy. Oh, where did I put my chuck key? I don't have it handy, but spinning it seems a little bit scratchy. So I thought, yeah, no problem. It's probably just grinding dust in there. I'll just take it apart and clean it out. Yeah, that's not gonna happen. These screws, I don't know how they were put in, but I do not think they are ever coming out. I'm not gonna put a torch on this thing because I don't wanna cook the lubricant or whatever's in there if I ultimately can't get it apart. But I've even put a high quality Allen wrench in there and pounded on it with a hammer with this held firmly in a wood vise, and I cannot get those screws to even budge. If I could get those screws to budge, then the thing's probably just got a couple of spring pins for alignment and I could pull it apart. But I have been completely unable to make it even move. In fact, yeah, there's the spring pins right there. So it's not coming apart anytime soon. The thing that really is gonna matter on this, even with it a little scratchy, I can live with that, or I can figure out how to take it apart later. The thing that really matters is we've got a face on the back that's gonna register against the back plate. And then we have a register in here that needs to be concentric and perpendicular to the ground surface at the front and the ground surface to register the collet in the back. And I don't really have a good way of measuring that without putting it on the lathe. So I think what we're gonna need to do is just machine the back plate and get this thing on the lathe. This is the back plate. Now, the back plate has been machined, and in theory, this can just screw, the instructions say just screw this right onto the spindle nose and then machine this side and the register and you'll be good to go. Except while this is the 1 3/4" thread, 1 3/4" 8 thread that's necessary for my spindle nose, this inside register is too small. So we're gonna have to bore that out. So I'm gonna need to chuck this up in the lathe, get it dialed in so that at least this surface is running true and the threads are running true so that I can then bore this out and have it be concentric with the threads. Indicating on threads is possible, but difficult. And so what I really need to figure out is how is this thing machined so that I know what surfaces I can trust. Now, I think the whole thing was held in a chuck in this way. And what would make sense to me is that they bored it out, machined all of the surfaces on this side, the register surface, the seating surface here, and these surfaces on the outside, and did the threads all in a single setup. I don't know that for certain, but I've taken some measurements to try to understand it. The first thing I did is I've measured with a depth micrometer from this surface down to this surface, and those seem to be parallel. This surface and the surfaces on the other side are definitely not parallel, so they were definitely done in a different setup. And as far as I can tell from what I've seen, again, these two surfaces being the same or being parallel to one another, it makes sense that the entire side here was done in one setup. Now they could just have totally screwed me on this by machining everything from this side except the threads, which they machined after they flipped it around and didn't indicate it in well. I mean, look at the price, it wasn't done carefully. But the only thing that would make sense and the only thing that I could actually salvage this part easily would be if those threads were done in the same setup with all the features on this side. So that's what we're going to go with. We're going to indicate it in using the surfaces on this side, and then I can check to make sure that the threads are concentric, and if they are, then we're good to go. We can bore this out, just touch all the surfaces on this side, and then we'll be in a position to throw this on the spindle nose and do the rest. Now, when I first started playing with this, these surfaces I was getting really strange and inconsistent measurements. So on a hunch, I took my precision flat ground stones here. These ones are from Kinetic Precision, and just dressed these surfaces. And what I discovered is kind of interesting. You can see 3 shiny spots, one here, and one here. And what that tells me is that after this surface was machined, it was then gripped in a 3-jaw chuck. And you probably can't see it, but right next to those shiny spots, there is a tiny flat spot on the surface here, at least a place where the tool marks are just a little bit shinier because it's been grabbed and distorted. And it was distorted enough to raise this material. But once I came back through with the flat stone and dressed that down until it stopped cutting, I just had those 3 high spots. This is now flat, and if I take a depth micrometer on here, this ends up being parallel to this, and it looks nice and clean. So I think the plan is going to be to chuck it up in the lathe in the 4-jaw chuck like this, and then make sure we've got it concentric, and then machine everything on this side. Let's go over to the lathe and get started. Okay, I'm going to set this in the jaws, but I'm going to leave it purposefully off of the steps here so that I can tap it in and get it running true later. So I'll pull it off of the back just a little bit. Just try to get a good grip here. Just enough for the grip that it won't go anywhere. And yay, that's all over the place. Yeah, let's bring in an indicator and see if we can get this thing dialed in. Call it enough from that direction, and let's start working on this direction. Okay, we're pretty close there. Let's switch back to the face. Just see how we're doing here. There we go. That's a few tenths. Okay, maybe about half a thou there. Now, just as a sanity check, let's check this register here, or check the face there. Yeah, that's basically not moving. And then one more sanity check. If we can come in at an angle and get on that inside register. Yep, and that's basically not moving. So I'm going to call that good. Okay, we've got this chucked up and flat, so all the surfaces are running true. And I want to check and see if the threads are also running true. So I've got my lathe set up for threading at 8 threads per inch. So as I turn this, I've got the half nuts engaged, so the carriage is moving back and forth at 8 threads per inch. And I've got a dial test indicator here, and I'm going to bring this in and try to get it where you can see it, and we'll set this on the inside of the thread. Try to get that close to 0 there. And that's pretty rough. Let me see if I can find a better surface. There we go. Adjust that to 0 or close to it. And now let's just run this through. There we go. It's rough, so we're bouncing around a little bit, but I'm watching that not varying more than about a half a thou from the 0. So I am convinced that we are running true on those threads as well. So those threads definitely were machined on the same setup with all these back surfaces. So we're all set up. Let's go in here and cut our bore. Okay, the first thing I want to do is get set up to get that bore machined. So I'll set up a boring bar here. This back on feed, make sure we don't have any ugly surprises. And let's get set up for our depth first. Now I've taken measurements off of another back plate that I have. I know I want the bore diameter to be 1.813 inches. Sorry, it's not metric. The dials on my machine are not metric. So this is what we've got. 1.813 in diameter, 0.55 inches deep, and then this outside needs to be 2.635 inches. So let's start by setting up this 0.55. So I'm going to run this down and just touch this outside surface, and then grab a dial indicator. Now I bring that into 0, and we want to go 0.55. So 1, 2, 3, 4, 5, 50, right there, and then now let me reset that on 0. Okay, so we'll come in, make 1 full revolution, stop on 0, and that will be our proper depth. Okay, let's do a little bit of turning. So I think I just took a skim off of the inside of the bore here, and I know the bore needs to go to 1.813, so let me just do a quick sanity check and just see where we actually are. .769. And because I'm super paranoid, I'm going to use a calculator. So 1.813 minus 1.769 divided by 2, which means I got to pull out 22 thou on the cross slide. So I am going to just do 5 and try to establish a good measure here, and then we'll actually start trying to hit our target. Take another measurement here. There we go, 1.813 and a couple of tenths. Okay, I'm going to take that. Looking at what's in here, I'm going to need to do a little bit of cleanup on that thread. Now let's take some light passes and clean up the outside of this thing. Okay, before I take this out of the chuck, I want to just pop this off and try screwing it on. So let's take the locking screws out. Go ahead and power down the lathe just to be sure. And the moment of truth. And there we go. I'm going to call that a success. Let's take off the 4-jaw chuck here. I think it's fine. Snug that back. Just make sure I'm not dropping all the weight at once. And there we go. Now that we've got the backing plate alone just mounted here on the spindle, we can spin it up and look at it. And I don't know if you can see that, but it is definitely running out on this side because this side is not parallel to the side we already machined. So let me grab a tool and let's just start by skimming all these surfaces and bringing them in true. Okay, immediate problem. It doesn't reach. I'm gonna have to take my shield off here. Ooh, nice. Well, the good news is it's oily and not rusty. Okay, how far can we reach now? Not very far. Okay. So we'll use the compound to get in there. This should be enough. Now let's see if we can reach it all. Got a little bit more overhang than I like on the using the compound here, but if we can get to the point where we can skim the entire surface, and it looks like we can, should be fine. try to get this cleaned up. There we go. Okay, now see how much depth we have here. I've wrote some measurements down. We want this to be this step to be 150 thou. So let's see where we are. It doesn't have to be that precise. We're at 136. I'm not measuring this precisely by any stretch. 148, 147, that will be just fine. Okay, now let's clean up the outside of that register. I'm just going to try to get it cleaned up to so that it's cleaned up all the way in, and then we'll start measuring and figuring out what diameter it needs to be. Okay, I know this register needs to be 3.739. I can't easily get a micrometer in here, so we're just going to have to make it a caliper dimension. It is 3.843 right now. .738. That should give me 1 thou clearance. Let's see how it actually fits. Oh, I need to put a little chamfer on there first. Okay, that is nice. Okay, the outside diameter needs to come down, but I think that register is going to be perfect. So the outside diameter has to come down to 4.981. Let's do that next. You're hearing it bog down just as it hits, but the reason for that is because I've got it on a relatively high speed belt, but I've got it slowed way down with the VFD, so the VFD hits a second and then increases torque. Okay, I think we're ready to mount this thing. The fact that it'll stay on a 150 thou register without falling off tells you something about how well it fits. Now these are the screws that came with it, so if I were smart, I would probably replace these with real alloy screws that I know the provenance of. Okay. Let's see how it spins. Okay, well, we've got the thing on the back plate. Let's put something in a collet and see how it goes. We've got a 1/2" collet here, and this is just a cheap collet. I don't even know what that brand is. It came with a Schar's tool grinder. And I've got a ground pin here, and I've got an Edge Technologies collet stop in here just for fun. So I can just put that in, and it will hit up against the collet stop. Let's find the pin here. Run this thing in. Put our pin in and see how close we get. See how it runs. There we go, and looks pretty good. Let's throw a dial indicator on that and see how close we actually are. Well, I can't complain about that at all. That is running about a 1/2 thou. Let me bring the camera down so you can see that a little bit better. That is running just about a 1/2 thou. Let's move out about 1 inch away. And we're running maybe 7/10, 8/10, something like that. That's not actually too bad. I want to try something. Let's try some. So this, there are 2 pinions here. This pinion is the one that's close. This is the one I used. This is the one that's close to the key screw for the collet. Let's loosen and retighten with this other pinion that's over by the oiler. Loosen that, retighten there, and let's see how that runs. Oh wow, that's running out quite a bit more. Let me try to get this zeroed and see exactly where that is. So that's about 1.5 thou that's running out if you tighten it with that one. Let me loosen and retighten with the one next to the key again. And we're back down to under a 1/2 thou. Okay, note to self. Always tighten using the pinion next to the key. I gotta say, 1/2 thou is way better than what I was expecting. I was not expecting for $150 and then my machining skills on the back plate to get us anywhere close to that kind of run out. That is significantly better than I was expecting for $150. So is this thing really great? Well, this is no hard-hinge HLVH, but you know, that machine's just a joy to work with. This is a cheap import lathe with a very cheap import collet closer, but I'll take it in terms of just having work to do, especially if I need to cut and trim pieces to length with the collet stop in there and get a bunch of them the same length. That will be way easier than using my 3-jaw, which incidentally doesn't run anywhere close to this kind of concentricity. So we'll see how it goes in the long run. We'll try it on some different projects and see how it works out. But for $150, including the semi-machine backplate, I cannot complain about that. If you'd like to see another way to put a collet chuck on a small lathe, check out Blondie Hacks today. Quinn has a new video showing how she put an ER collet chuck on her lathe. And I will put a link down in the description. Well, that's all I've got for you today. If you enjoyed this video, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. You buy anything cheap like this on eBay? How did it work out? Was it good? Was it bad? Were you able to fix it? Leave your comments down below and let us all know. Thanks for watching.